Most of security metrics we introduced in previous units are raw data or simple observations. In order to fit them for decision-making dashboards and triggering actions, they need to be contextualized, processed, fused with other relevant data, and be analyzed. Here is a set of a common descriptive analytics method for security data. Grouping and aggregation through summary statistics, such as average, median, standard deviation. Time series analysis, cross-sectional analysis, quartile analysis, correlation matrix. What describe core concepts of each method, what they mean, and how they are constructed. The techniques themselves are generic and not specific to security. In addition, we'll provide some guidance in the form of use cases and example data sets. In descriptive analytics, summary statistics are used to summarize, group, or aggregate a set of observations in order to communicate the largest amount of information as simply as possible. The arithmetic mean serves as a standard aggregation technique. It is the sum of a collection of numbers divided by the number of numbers in the collection. While the arithmetic mean is often used to report central tendency, or in other words, to characterize what is typical, it is a not robust statistic, meaning that it is greatly influenced by outliers, values that are very much larger or smaller than most of the values. In many cases, the typical might have been better off using the median rather than the arithmetic mean. The median of a data set is the number that separates the top 50% of elements from the bottom when sorted in order. In other words, a data set's median indicates the point where half of the elements lie above it and half below it. Like arithmetic mean, medians help aggregate data sets into smaller sets by summarizing a range of records. However, medians offer more insights for understanding the 80-20 rule for performance-related data, particularly if outliers present. For example, consider a password auditing tool that determines the number of seconds needed to crack user account credentials. If the mean time to crack 1,000 password was 1,344 seconds, but the median is 822 seconds, that would tend to suggest that outliers might have distorted the average and therefore painted a rosier picture. In short, medians offer more significant advantages over means, particularly with respect to measuring performance. Variance and standard deviation are also summary statistics. Variance is the average of the square differences from the mean. Standard deviation represented as a sigma. It is a measure of how spread out numbers are. It is the square root of the variance. These summary statistics can be easily calculated in Excel, R, or Python using shortcut function or statistical library. The box plot, or box and whisker diagram, is a standardized way of displaying the data distribution based on the 5-number summary, such as a minimum, lower quantile, median, upper quartile, and maximum. In the simplest box plot, the central rectangle spans the lower quartile to the upper quartile, the interquartile range, or IQR. A segment inside the rectangle shows the median, and the whiskers above and below the box shows the locations of the minimum and maximum. This simplest possible box plot displays the full range of variation from minimum to maximum, and the likely range of variation, the IQR, and a typical value, the median. Not commonly real data set will display surprisingly high maximum or surprisingly low minimums called outliers.